Am I moving? You would say, no, come on, you're just standing there. What are you talking about? But that's because we are not thinking quadridimensionally. In fact, me, you, everybody in this room, we are moving in time constantly. And the great idea of Einstein was that to consider time as just another direction, as moving to the right or moving to the left, forward or backwards. And the same with time, with only one big difference. You cannot stand still in time. You have to keep flowing. Okay, let's make it simple. Let's consider there's only one direction in space we can move, right or left. And let's consider time flowing upwards. Okay, so there is the first guy. Let's call it Francesco number 1, to be crazy. And this guy is just sitting there, okay? But time flows, so he will move in the space-time, reaching this point in the future. And then there is another guy, Francesco number 2, which also wants to move in space. So he will go to the right, but of course time will pass, so he will go also up and then back to the left, joining Francesco number 1 and the same space-time point, meaning same point in time and same point in space. Now the question is, which of the two paths is the shortest? I don't know, it's crazy, right? But the shortest one is the second, actually, the one that moves first to the right and then to the left. And this is because of the crazy geometry that our space-time where we live has. And it gets even weirder, right? Because since the path is shorter, also the time that the second Francesco will measure with this clock will be less than the time measured by the first Francesco when they meet again. So they meet, they compare their time, and Francesco number 2 will say, oh, but I took less time than you. Crazy, right? Now you can tell me, come on, this is all like crazy theoretical physicists that say this kind of stuff. But actually, it's something that we can prove. If we have two clocks and we put one on a satellite and one we keep it here on Earth, and the one on the satellite goes around and around very fast, then we take them back, we compare them. The one on the satellite, because of this effect, will measure less time passed than the one that remained on Earth. And this is something we have to use every day to get correct geolocalization with our GPS in our phone. The first time I heard this, I was like, come on, why aren't the physicists just flying on spaceship to beat time and study even more physics, right? I was like, come on. But actually, the thing is that for me, if I'm moving or if I'm staying, my time will pass at the same way. 1 second in my clock will take 1 second for me to pass. Therefore, there's no point in trying to go as fast as possible. Yeah.